I think this is going to be a really exciting panel. Tree and Vipul, I'm excited to chat with you guys. Tree, I wanted to start out by talking about optimization. And, obviously, I think a lot of folks here are a big fan of your work in this area, in particular, across all the things you're doing, both on the architecture side as well as on the optimization kernel side. I'm curious, what do you think is going to be the next 10x kind of opportunity in terms of optimization? Is it more on the architecture side, more on the kernel side, both, something new?
Right. Yeah, I think that's a great question. I think the cost of AI has actually dropped, I don't know, 10x of 5x every year, which is crazy. But I think that's going to keep going. And my guess is in the next year or so, it'll drop another 10x, right? And where's that 10x going to come from? I think it's a combination of things that you mentioned. There is the model architecture, there's the kernel. I think there's also the hardware. Hardware is changing. So I'm guessing on the model architecture side, as people figure out what are the workloads that most people are serving on, is it batch inference, is it agentic workflow, that they will tailor and optimize the model architecture for that. I think that's going to be like 2-3x. There are a bunch of really exciting work on the inference algorithm side. So we see examples for speculative decoding coming out of Google a couple of years ago. We see more and more of that because I think, to be honest, currently the inference systems don't use the hardware very well. They maximize the memory bandwidth, but they don't use the flops very well. And I think there'll be new methods coming out that somehow convert the flops into reducing memory bandwidth and serve models much faster and much more lower cost. So that's the second factor, which is there's kernel or inference algorithm optimization. I think the last one is on the hardware side. So people seem to have realized that hardware should now be designed with inference in mind, right? NVIDIA is realizing that. Google is doing that. Tons of startups are now designing silicon specifically for inference, right? And once you have a workload that you can optimize for, these hardware designers can do amazing things. And I think the cost will drop 2 to 5x within the next couple of years. So I think it's a combination of things, the model architecture, kernel and inference algorithm, and hardware.
Yeah, that makes sense. I actually wanted to double click on one of the first things that you mentioned around workload-specific optimizations, right? And so, you mentioned batch kind of throughput-oriented workloads versus latency-oriented workloads. Can you give some examples of what you think are opportunities, particularly for throughput-optimized workloads that you're seeing?
Right. Yeah, so we're from talking to tons of teams at different companies, we see a bunch of use cases for batch inference, things like they're processing massive amount of documents, and they don't need the results to come back in the next 500 millisecond. Then you can batch much more aggressively. You can do a lot more caching and so on. So in some sense, you're from the hardware perspective, the more you can batch, the higher the compute you can use, and these chips they have massive amount of compute that most of the time, if you don't batch, you're not really maximizing. So that's one workload that we're seeing. The second is around these reasoning models, like deep research kind of model, where they're trying out tons and tons of ways to solve a problem, right? So that's why these thinking models can do amazingly well at math and coding and so on. So in this scenario, a model is trying out, let's say, 10 to 100, maybe thousands of different ways to solve the same coding or math problem. And then they would check, hey, does this, one of these trajectories or one of these solutions actually work? So so you're doing batch of hundreds. Ideally, we want to go to thousands or tens of thousands. And we've seen, the amazing thing is this scaling law, where we've seen the more trajectories you try out, the better the model. That's been the recent trend. So those are the two use cases from talking to companies that we're seeing, either batch document processing or these reasoning models.
Makes sense. And also wanted to commend you and your group for doing a lot of this work in the open source. Given that there's all these closed source kind of model companies, they're also doing inference optimization. I think there's a group of people doing it in the open source. What's your take on these kinds of optimizations kind of actually making it out there into the community? How can that happen more?
Right. I think we're seeing a very vibrant sort of open source community. So academics are still doing excellent work around this area. People publishing papers and code. Labs like some from China, like DeepSeek and Alibaba and so on, are putting out excellent models, and not just models. They're putting out a sort of infrastructure to run these models. We have amazing open source libraries like VLM, SGLang, and so on. That I think all of a sudden get a bunch of people really, really excited. There are AI enthusiasts that are now contributing to these open source projects. So I think it will keep going. The Frontier Labs, I do talk to them. I mean, some of them actually do use these open source tools. I think XAI was explicit that they're using SGLang and so on. So like everyone else sort of building on the same infrastructure. I think that the difference would be for different companies, they would tailor to a particular kind of workload. From some of the customers we talk to, maybe they care more about throughput versus latency. Maybe they care more about prompt caching. Maybe they care more about interactivity. Maybe they care more about agentic workflow. So there's custom work to be done, but I think there's a very strong foundation from these open source projects.
Yeah, makes sense. Vipul, I wanted to get your take as well. How do you think about how NVIDIA is kind of moving to a 1-year release cycle? What do you think are the opportunities left in hardware to improve the performance and cost?
Yeah, I think one of the things you're seeing very clearly is that intelligence per watt is going up, and it's a fairly steep curve, which one, I think it suggests that this hardware cycle is going to move pretty quickly. We are trying to apply more and more power to computation in a concentrated way. I thought the CPX announcement it was pretty interesting. It's taking the inference workload, disaggregating it. The prefill phase has a very different sort of computational profile. If you speed that up, that will have a huge impact on the overall cost of inference as well as long context. Right? You can now sort of do 200,000 million tokens of context through these models for effectively the same cost and do it pretty quickly. So I think you have the architecture of transformers has sort of become this homogeneous target, which now allows and it's evolving for sure. Like we've had a lot of optimizations in it, from faster attention mechanisms, MOE. But now hardware is starting to adapt to this workload because the workload is somewhat more constant relative to the hardware.
Yeah, okay, makes sense. I mean, I guess at this point, you guys are buying a lot of GPUs, putting a lot of them together, right? How do you think about making GPU purchases as the industry for hardware is moving so fast? For example, how do you think about depreciating that out? How many years is one piece of hardware useful?
Yeah, so I guess our broader view on this is probably the largest infrastructure construction cycle in human history. If you think about what it takes to generate a token on DeepSeek V3, it's 250 gigaflops to generate a token. And as the models are getting better, you have more and more downstream applications that are appearing. We need a lot of computation. So I think we are probably at 1 or 2% of what we would need in 10 years. And I think because of the fast hardware cycle, the life where at Together we sort of take a conservative view on how long that life cycle is. And the opportunity there is really how do you maximize the utilization of the hardware over its life cycle. And this is where I think the AI clouds differ from hyperscaler approach, which was buy a lot of chips, put them on the side, wait for the workloads to sort of scale up and down. Where this is a very sort of hyper utilization approach, where you're creating a product or a suite of products that invite a diversity of workloads to keep your infrastructure utilized, high 90s percentage.
So it basically sounds like, you're more in control of the shape of your demand because you're also providing a lot of high value services on top of that raw infrastructure, right? What do you think that the rise of these like kind of more neo clouds means? What does that mean for the startup ecosystem? What do you see as the future of how people go and buy their compute 5 years from now, right? Because I would say in the last 5 years, people often default to one cloud, which is, their cloud, and they buy most of the compute from there.
Yeah, I think what being focused on generative AI workload has advantages. You're sort of building infrastructure that is generally sort of lower cost, is designed for scale, and scale comes not just from current data centers, but how they can extend, where the power capacity is coming from. So the planning cycle, the kind of operational costs are really kind of tweaked for AI workloads. I think for startups, it means you have more flexible access to compute. And the approach that we are taking is that there's the sort of substrate of hardware and silicon, but there's also very sort of optimized functions on top of it for core operations like training and inference. And it allows startups to just sort of go, get up and running really, really rapidly.
Yeah, makes sense. I mean, I think we're seeing the same thing at Databricks, right? Like there's all sorts of new replatformization because there's a new kind of workload that's so special. I wanted to talk about open source as well, right? I mean, I think we've all seen kind of open source models have had, their ups and downs. Nowadays, I would say like, Chinese models like Qwen, DeepSeek, Kimi are really dominating the market. What's your view on the future of the open source model kind of community, and what's the niche that you see for open models going forward?
I think one of the things that we're seeing right now is with open source models, AI applications, especially like scaled up AI applications, they have a lot of control over performance cost. It's a with closed APIs, you sort of get what you get in terms of latency, in terms of capacity. With open models, you really have a lot more control over that, and we pretty broadly see this trend where applications are using closed APIs as well as using open models. I think the other thing that we're seeing with reinforcement learning, you're able to adapt these models continuously to the application, and it's for many of the apps, it's actually producing more capability and a better model than a closed source model. And so it's both capability and price performance and scalability. So I think that in some ways the quality of the base model matters, but it doesn't matter that much because you're sort of heavily post-training it afterwards.
Yeah, no, makes sense. I think this, the folks from Sakana talked about this earlier today as well, right? I do think there's a future where a single application is using a bunch of different kinds of models. And with open models, as you said, right, like I don't think there have been in history huge scale applications that have completely kind of given the reins to a different service that may or may not be up, may or may not have good latency. So it makes sense. Tree, I'm curious on your take as well.
Right. Yeah, I want to echo this point. Like we want models to get better and better the more you use them, right? And so maybe you start out, you want the easiest thing to do and to prompt, and so you open up a website and ChatGPT or Claude and whatever. But as you build out your product, you want to think about the moats. Like, what moat do I have? Okay, maybe it's user data. Maybe you start to understand the use cases better, and you start to then want to your model to get better and better, right? And so that requires a certain level of tailoring, fine tuning, reinforcement learning, what have you. And so you really want control of the model at the end of the day. So that's what we're seeing a lot of use cases, actually. So Cursor starts out mostly people were using Cursor with Anthropic model, but now I think there's some trend that they might be training their own models because maybe they understand that application area really well. They have good data. So I think that's going to be the trend where maybe you start out with the easiest thing, and then as you build and thinking about the moat and want your models to get better and better, like open source models provide an excellent platform to build on top of that. So if that's the future, then we want to think about, okay, what kind of infrastructure do you want to build on top of open source models? Things like inference, fine tuning, reinforcement learning. So those are some of the areas we're working on as well.
Right. Yeah. No, I think that makes sense. Maybe a question to both of you. What do you see as the path forward for the U.S. as China is kind of doubling down on open models, where the U.S. is there's Meta that was producing open source models. What do you think the future there is going to be? Maybe it relates to like the economic model for them, for example.
Yeah, I mean, I think one of the things we will see, and we're already seeing this, is that labs that are doing closed models are also starting to produce open models, right? From Gemma to GPT OSS. And I think you sort of have this game theoretic framework in the market where if you, open source is going to be a big portion of the workloads. And if you are not participating in that, you're sort of ceding the ecosystem to, another company. And I think that's one of the trends that's sort of naturally present and is producing open models. I think there is more investment in open models coming from the startup ecosystem, the venture ecosystem, silicon manufacturers. So I expect, we haven't seen a sort of a sort of cadence mismatch between open source and closed source today. They tend to be fairly closely aligned in terms of capabilities, and I expect that will continue to happen.
Right, and beyond just the models, which are very important, these base models you build on, but I think a lot the gap usually comes from: do you have the right infrastructure? Do you have the right data? Do you have the right reinforcement learning environment to build on top of these models? So I think that's actually the place where open source sort of open source community could have a large impact, is these more at the infrastructure and data level. So we see great open source projects on inference, then open source projects on doing RL training for these models, or collecting data sets, or building RL environments. I think that's where the most exciting progress on the open source side will happen in the next couple of years.
Yeah, no, I completely agree. I think, open source has for many, many years been used to, commoditize when your competitors are gaining an advantage, right? And given that this is not a monopoly market, I think it makes a ton of sense that people will continue investing. Last minute here, I wanted to just, up level from this and say what, we all kind of work with different enterprises on exciting applications of Gen AI. What is the most exciting application you've seen that maybe other people don't know about, or that's exciting to you?
I think chatbots are great, and that's been the case for the last 2 years. I think the next couple of years will be coming from how do you build like expert level AI. Right. So anything that's on the internet, these models can do really well. Front end building websites, they're great. But I think most of the economic value is coming from experts working with tools. And I think the most exciting thing is probably how do you get these tools, things like hardware designer working with their simulation. How do you get AI to start doing some of this stuff?
Yeah, I think one of the things that I personally get very excited about is we've done a lot of infrastructure and the tooling now that is, managing this infrastructure, being able to do, anomaly detection and automatic remediation of this is really cool. It's like it provides incredible scale to what we are building, and it sort of is hidden under the covers, but it's having a pretty massive impact.
Yeah, definitely agree. I mean, I would say that for myself, like the amount of unprocessed text data that exists in enterprises that people are now dusting off because previously they couldn't, analyze it at high enough intelligence and low enough cost is so tremendous. Probably most people are not seeing. I would say chatbots are probably the most common way people interact with AI right now. All right. I think that's it. Thanks, everyone.